Alright, so let's go ahead and get started again. I believe we were talking about standard deviation, which is the average distance from the mean of each point in the data set. And we're looking at an example with a data set of 3 points. Suppose you are factory manager and you have 3 employees that produce widgets, and these 3 employees over the course of a shift produce 3, 6, and 7 widgets respectively. What is your standard deviation? And tell me how you calculate it. Well, we've got the mean and standard deviation here. Somebody tell me what's going on here. How am I calculating a mean, population mean of 1.7 widgets? What did I do to get that?
The mean?
Well, I want population standard deviation. Why do I need to know the mean first? Let's start there. Michael?
Because you have to add everything up. And then you divide it by
Right.
your populated by, sorry.
Go ahead. Why do I need the mean first? Why is that the first step?
Oh, because you need to know the distance from that, that's your core.
Exactly.
Sorry.
Standard deviation is the average distance from it. So the very first thing I need is the mean. What's the next step, Kathy?
The next step is to plug into the equation,
Distance from it.
and the sum you subtract it by the,
Alright, what's going on at each of these points here? Help us out, Henry. What's this and what's this?
So you're taking each value and subtracting the mean
from it.
from it.
Yeah,
And-
each value, the difference between that and the mean. Is it a positive or a negative? We don't care,
Yeah.
so we square it. Then we add those all up, divide by the number of employees, take the square root to get back in normal terms, we come out to 1.7. So 1.7 is the average distance from the mean of each of these 3 data points. And that seems to make sense. If the mean is 5.3 widgets, the average distance from the mean of these 3 is about 1.7. Like, let's look at number 3, or for 3, that's 2.3 away. Alright, for number 6, that's like 0.7 away. And number 7, that's like 1.7 away. Alright, so, add those all up, divide by 3, we get about 1.7. Alright, but we do it a little more scientifically like this, and we get that. Alright, so that's the population standard deviation. Now suppose that this was not our whole population. These 3 employees were just a sample out of 16 total. In that case, we would have a sample standard deviation, which would be slightly different. How do we calculate the sample standard deviation? What's the difference we do? Oh yeah, what's different about how we calculate the sample standard deviation?
2.
Yeah, 2, right? Why is this 2? This is that what you mean?
10 minus 1.
We did the negative one, minus 1.
Yeah, exactly, 3 minus 1, and notice that this is a little bit bigger than this. Why did we say this is going to be a little bit bigger? Why do statisticians want a slightly bigger number?
This is a broader forecast.
Yeah, we give a broader forecast to account for the unknown factors. Right here we just have a sample of 3, and we may be trying to estimate the whole 16. So we want a slightly larger number, give us a broader forecast.
What would you say, to account for?
The unknown factors. Alright, so let's see, we have at this point everything we need to know to quantify certain things in normally distributed data. We know what standard deviation is, we know what the mean is, 2 parameters, the mean and the standard deviation, alright, is what we will find we need to quantify things on a normal distribution. So let's take a look. Let's go back to a normally distributed data, classic bell curve. It has a mean, median, and mode that are all equal to each other. and we, for our purposes, are going to be using the term mean. It has a standard deviation that we can calculate with the way that we just calculated it. And here's the thing about normally distributed data, is that the percentage of data within a given number of standard deviations is predictable. Remember we said there's an equal probability of being a little bit taller of a tree as to being a little bit shorter of a tree. And that equalness of probability is symmetrical throughout the whole distribution. So all we need to know is, once we know that this is normally distributed, i.e. symmetrical, we just need to know how skinny or how fat this distribution is. A skinny distribution would have a small standard deviation. A fat distribution would have a big standard deviation. Once we know that, then we know how much data is within any number of standard deviations. Reason for that is because that's just the way the law of probability works out. The way the law of probability allows us to quantify the likelihood of any points of data being within predictable numbers of standard deviations. Now let me show you a couple of the things that we know, and these are just a few of the things we know, which we'll toss out from time to time. 1. Approximately 68.3% of the values in the normally distribution will be within one standard deviation of the mean. Okay, so that's 68.3% of the trees are within one standard deviation of the mean.
So this is in all cases, you mean?
In all cases.
Okay.
In all cases of normally distributed data. 68.3% of the families in New Jersey are within one standard deviation of the mean. 68.3% of all families in a completely other town in Alabama that has normally distributed data are within one standard deviation of the mean. The reason is because if this is a situation where there's a chance of being a little bit richer, a little bit poorer, and that probability stays equal, all we need to know is the average distance. And that likelihood and probability stays the same and stays predictable as we go further and further out in the distribution. A law of nature that, actually let me go back to this slide. Remember I mentioned this guy earlier? I didn't say his name, I don't even know how to pronounce his name, but a German mathematician who discovered the normal distribution. This is what he discovered. He said, oh my God. Well, it happens in all cases where the data is normally distributed. It happens in sizes of trees, the weight of newborn babies, all other sorts of natural phenomena, all other sorts of things. Right. What else do we know? Approximately 95.5% of the values will be within two standard deviations of the mean. Approximately 99.7% will be within three standard deviations of the mean. So we know this. We also know everything in between. I can tell you, or you will soon be able to tell me before the end of the class, how much of the data will be within 1.94 standard deviations of the mean. Alright, we'll be within a half of standard deviation. Any number we pick, any percentage we pick, you can work backwards, work forwards, you can tell me exactly what percentage of the data is with any section, with any probability, yada yada. And the way that we quantify that is we put any normally distributed data, we can give it a quantity that we'll call a z-score. A z-score for any particular point of data is the number of standard deviations above or below the mean. So, if we have a tree that's 1.5 standard deviations above the mean, we'll give it a z-score of 1.5. If we have a family that's making 1.6 standard deviations below the mean, that amount of income, then we would give that family a z-score of -1.6. And if that data is normally distributed, we could say, what's the likelihood of that family making that amount of money? What percentage of families are making less? What percentage of families are making more? We can do all that sort of stuff with our z-score, and because we can assume that the data is normally distributed. Alright, so let's talk about that z-score. Let's calculate z-scores. So the z-score, as I mentioned, is number of standard deviations above or below the mean. So we take the difference between any particular point of data x and the mean, the population mean. Alright, how big of a difference is that? And we divide by standard deviation. So if the mean is 6 feet, my particular tree is 8 feet tall, alright, this is going to be 2 divided by standard deviation of say 1, alright, then 2 divided by 1 is 2. I have a tree with a z-score of 2. And I could look on a table that adds up the probability of having a z-score of 2, and I could glean some more information. We're going to do that in a moment. Now this z-score could be positive or negative. A positive z-score means that that particular point of data is above the mean. A negative z-score means that particular point of data is below the mean. Alright. So let's look at this z-score table. Let's do that. Okay, I've got one really small one in the slides, and I've got one slightly bigger one at the end. If you have your textbook, pull it out now. Henry has a textbook, so if I were you all, I would be friends with Henry. Alright, so how the z-score works, so this z-table works. Alright, is this z-table on the back of the book will tell us the probability of any other point of data having a z-score less than that particular z-score. Alright, if that went over your head, don't worry, we're going to spend plenty of time on this. So suppose I have a z-score of 0. What does that mean?
Means you're the mean.
Means I am the mean. I am the exact middle. Alright, if I take my height of me, and I'm a tree, minus the mean, I get 0. Divide by whatever the standard deviation, 0 divided by standard deviation is going to be 0. So I'm going to have a z-score of 0. So I want to now look on the table and find out what's the likelihood of being shorter, of having a shorter tree than me. So I'm going to look at this z-table, and I'm going to look at a z-score of 0. I'm going to move over to this column, 0.0, and I'm going to see 0.50. That means 50% of the data is shorter than me, less than me. 50% of the data will have a z-score less than me. 50% of the data will have a z-score higher than me. Alright, now let's say instead I have a z-score of 2. Alright, I think we just did an example, right? If I'm an 8-foot tall tree, or if I have an 8-foot tall tree, the average is 6, so that's 2. Say the standard deviation is 1. 2 divided by 1 is 2. So if I have a z-score of 2, sort of what percentile am I in? How much data is less, or has a z-score less than that particular tree? Well, how this z-table works is you look on this z column here, you scroll down to 2, and if it's just 2 even, then you go right to this column where it's 2.00. Alright, if we're at 2.01 or 2.02, I would go over in columns. But since it's just 2.2, 2 point even, I am going to look at this number, it's gonna say 0.9772. Alright, what does that mean? My tree has a z-score of 2, and that says 0.9772. How do I interpret that?
Means that your tree is higher than 97%?
Exactly. My tree, that particular tree is higher than 97.72% of the data, of the other trees. What percentage of the trees are taller than that particular tree?
The other 3%.
Yeah, the other 2.3%,
2.5.
or 2.3%. Okay, good, does that make sense? Now, let's go back to the slides, and let's take a look at the example. Right. Suppose I've got a family, a tree, or whatever, with a z-score of 1.2. I want to know how much area under the curve there is below 1.2. Another way of saying that would be, what's the probability of having a z-score of less than 1.2? So let's look at the z-table. I've got this on a slide here, just to make it easier for you on the next slide. So z-score of 1.2, it's 1.2 even, it's not 1.26. If it were 1.26, we'd have to go out here. It's just 1.2 even. So I see under 1.20, 0.8849. What does that mean? Come?
That tree or whatever it is taller than 88% of the other trees.
Perfect, exactly. 88.5% of the rest of the trees are shorter. Whatever, 11.5% are taller. Perfect. All right, we can look at the z-score two ways. We can calculate a z-score for a given point of data and do just as Calvin did. We can say that tree is taller than 88.5% of other trees. The other thing we can do is we can say, I wonder what the cutoff for 90% is. I wonder what the top 10% of trees, I wonder how tall they are. And then we can look for the 90% in the middle of that z-table. And we can say, what's the z-score that requires 90% of the data be less than it? We'll answer questions like that as well. All right, great. I think I wanted to go through an example. It may sound familiar to you if you had me for Turbo a month ago, but it's good to refresh. Let's do an example of typical male height. Suppose that's something that's normally distributed. And we'll think about how we can quantify certain individuals with a certain height within this normal distribution. So, let's suppose the average male height for a male is 70 inches, and the standard deviation is 3.5 inches. And in this case, we can assume that the standard distribution is normal. Further suppose LeBron James has a height of 80 inches. What is the z-score that represents LeBron James's height? Alright. How do we calculate the z-score for LeBron James? Help us out, Henry.
So the mean is 70 and the standard deviation is 3.5. So you say you would take it'll be in the, how do I say this? It'll be at the 95.5?
Well, we're not there yet.
Oh,
We first need the z-score. Catherine, how do we get the z-score?
I believe it's LeBron's height of 80
Yep.
minus
Oh, yeah.
the 70, which is the
Yep.
mean, over the standard deviation, which is 3.5.
Perfect. Alright, what's that come out to?
2.857.
2.857. Fantastic. Nice even number. Alright, so we've got a z-score for LeBron James. We're rocking and rolling. Next question. What is the probability that a randomly selected American male will be shorter than LeBron James? How do we find that out? Go to the table. Alright, we go to the table, we find the z, 2.86. Alright, we find the probability of having a z-score of less than that.
99.7.
How much?
It's 99.79%.
99.79%,
Yeah.
so about 99.8%. Wow, alright, so LeBron is pretty tall compared to just about everyone else. Okay, so and everyone see how she did that? She looked for the z of 2.86, and the area under the curve associated with that z-score was 99.79%. Alright, let's go on. Suppose Isaiah Thomas has a height of 69 inches. What is the z-score for his height? Z for Isaiah Thomas. Alright, help us out, Stephanie.
So for that one, we do x is 69
Okay,
minus 70
okay,
over 3.5.
perfect. Alright, what's that come out to?
.2857.
Alright, I don't like it for a number of reasons. What's the thing I dislike most about her answer?
Under zero.
What's that? It's
It's not negative.
It's not negative, alright, so it needs to be negative.
Oh,
Why
it
does
is
it need to
negative,
be
sorry.
negative? Alright, so, alright,
I didn't see the minus on top.
negative. Alright, so Isaiah Thomas is shorter than the average male, so he should have a z-score that is negative. Negative 0.285. Is that, and I guess that's, I could go with that. About a z-score of negative 0.285. Alright, so we're good there? We got the z-score? Now, what's the probability of a randomly selected American male being shorter than Isaiah Thomas? Alright, we've got to go to the table, for sure. Now, Henry actually has a negative z-score table. You all do not have a negative z-score table. So it's easier for him to figure this out, but you can still figure it out with the z-table that you have. The reason you can is because positive and negative are mirror opposites of each other. You can just do a 1 minus type deal. You can look on the positive side for a z-score of 0.285 or 0.29,
Subtract from
1 minus that number. Alright, what do you get, Catherine?
Sorry, I was writing.
No problem. Anyone have the answer? Oh, go for it, Stephanie.
Well, it's a percentage, right? So
Yes.
it's 38.97%.
38.97%. I could be okay with that. Yeah, I could be okay with that. Henry, you like that?
It's close. It's pretty much the same number. On the negative it says 38.59, but
38.59,
it's
38.
same, pretty much the same.
Oh, okay, wait, but the positive and negative should say the same thing, right?
Oh, maybe I'm reading it wrong. So in negative 0.2, 0.9.
Oh, it's 0.9?
0.29, sorry. So it's 0.3859.
0.38, huh? You okay with, are you okay with this change, Stephanie?
Yes.
0.3859? Alright, good. So you can do that by looking at the negative side of the z-table, or you can look at the positive side of the z-table. And what do you see when you look at the positive 0.29? It gives you, what, like 60,
61.41.
61.41?
I mean, 0.6141, sorry.
Yep, so you take 1 minus that number, and you should get this,
Oh,
right? Okay, good, fantastic. All right, what's the probability the randomly selected American male will have a height in between Isaiah Thomas and LeBron James? All right, I'll give you a hint. You do not need to go to the table for this one.
yeah, you just look at LeBron and Isaiah and take everything in the middle.
Exactly. All right, so check it out. So the probability of being shorter, let's see, so LeBron is here. This is LeBron James is here. All right, and we've got Isaiah Thomas is about here. Isaiah Thomas. All right. So we're looking for the area under the curve in between these two ball players. So there's a number of ways we can do this. We could take this minus this. That would give us the answer. Sometimes I find a better way to think about it is say, well, what is this? All right, and what is this? And subtract both of those from 100. That way I don't get confused in my head. Either of those strategies would work. Let's see. Let's actually just do it straight. Let's first just do it straight from the numbers that we have. We know that this is at the 99.79% mark. And we know that this is at the 38.6% mark. So let's just take the difference between those two. And what do we get?
61.2.
All right, so 61.2%. So that is the answer to the question. All right, the chance of the next male who walks by having a height between Isaiah Thomas and LeBron James, there's a 61.2% of that probability. So if we wanted to, we could stay here a really long time. And like every male that comes by, how tall are you, how tall are you? We do that for several days. We add them all up and we say, wow, about 61.2% we're in between Isaiah Thomas and LeBron James. Let's answer this same question in an alternative way. Let's figure out what percentage of the data is here. And let's figure out what percentage of the data is here. All right, what percentage of the data is here, taller than LeBron James?
100 minus 99.79.
Yeah, what percentage is that?
Which is 0.21.
0.21%?
Yes.
Okay, fine. What percentage of the data is here, shorter than Isaiah Thomas? Now we don't have to think too hard on this one.
Oh, it's just 38. It's-
Yep, 38.6%. 38.59%. All right, so let's use these two numbers to calculate this. Like I said, sometimes this is an easier way, I think, because I don't get confused in my head. So I take 100 minus this, and I'll get 61.2%. Any questions?
How did you get the 0.221 again? Sorry.
Henry took 99.79%, and the
Oh.
difference between that and 100.
Okay.
Alright, great. Let's try a couple of the problems in the textbook. Oh, no, let's do this one. We've got this one. Alright, this is fun. Are we ready for the next one? Any questions about that? Alright. Suppose the driving distance to work for certain residents of a certain community has a mean of 21 miles, a standard deviation of 3.6 miles. So, people who live in this town, on average, their drive to work is 21 miles. That's just an average, standard deviation is 3.6. Question for you all, what is the probability that an individual drives between 19 and 26 miles to work? Alright, let's solve this one in teams. Alright, so get with your teams, try to explain to each other how this Z distribution works, explain to each other how to read the table, and let's reconvene in 4 or so minutes with the answers.
Nineteen minus 21, that would be 2.
Right.
Divided by
That's what you have to do first.
2 minus
Yeah, so then the C's movable.
So we're finding the weak ball,
Z
and
squared.
then circle.
And the Z squared.
So it's two different.
Yeah.
And then we're basically doing, I believe, we're basically doing the same. Mm-hmm.
27. Yeah.
So I'm thinking, see, this, I gotta do this because I know. So it says, it says P19, so it's negative, so 5.
So we can do 0.5.
Oh, yeah.
Well, that's a negative, so we have to do the opposite,
So you
so
guys- you guys get,
0.55. So it's
You guys got negative
it's this one,
0.5 and 1.3.
Maybe I did it wrong.
Oh, you already did the whole thing?
Easy stuff, right?
Yeah.
Oh. Alright.
Easy process of it.
Oh, good.
So then,
Oh, yeah, so minus 2.
equals 2912.
So keep it.
See, that's what I've been doing. It's good.
And then equals Z, so.
Equal what? What was it?
2912. Because remember, since that one's a negative,
Yeah.
we have to do the reverse. So then the other one
It's
is
positive, so it's
1.38.
Perfect. Straight down the middle.
9162.
So you got.
Is that right?
Mm-hmm.
So, well, that second one, did you do the positive equal one? Yeah, so the second one is 91. The positive is
Subtract
equal,
them, right?
1.38, right? And then the percentage is
The
91.62,
bottom.
right?
Yeah, that's right. These are, this is the six.
Do this, do 19 minus 2. So that's,
For the question. So let's assume, let me do this one, because this is where I so we just took the difference, right?
Mm-hmm.
So that's 13.5,
Yeah, because this one was, you have to subtract this number, because it's 0.55, right?
Yeah.
And then you subtract this number, 1.
this
That
is
stays the same because it's
Question.
Okay, this is 29. Well, yeah. So that's 29.12%.
Yeah, minus
Uh,
91.62 minus 29.
Put the lowest one. Put the 100 miles an hour. Put the one up.
129 too.
It's crazy how it was the normal at the top, but they're still close to each other.
Mm-hmm.
That's how close it is. Okay, the number items.
Oh, so just everything between, yeah, everything between 30 and.
Yeah, the rest of them.
You put the wrong number?
This is
Yeah. So 50.
6. So to me, it gave me, because I was just deleted it.
Oh,
It gave me
18 minus 21.
18 minus 21.
What? Rounding up.
I'm gonna dip this one right now, it's gonna be
0.56.
Oh, you didn't. No, you didn't. That's nothing.
Because the other one should be fine.
Guys got it?
Where'd you go for the second?
What's the answer, guys?
Second? Where'd you go for the second?
Did we,
91.62.
Okay, so we put 9.
What did we get?
Yeah, what you mean?
5%.
You two have the answer?
We have 62.
62.57. All right. Okay, 60. You got, how much did you get? 45? All right, we do have two different answers. I guess that must mean that one team is wrong. I guess, I mean, we can't live in a world where we have two right answers to statistics. But that is fine, because we're here to learn.
Possibly which one's
All right, so in this case, we need two z-scores, and we need the area probability between them. So the first z-score we need is for 19. What do we get for that? The difference between 19 and the mean divided by standard deviation is what?
Oh, negative 2.5.
Negative 0.5 even?
We got 5, 5.
How much? 5.5?
Yeah, it's like
Yeah,
5.
Yeah, it's
all the way.
555.
Yeah. All right. So what I recommend you do is leave this number in your calculator. Store it somehow, so that because you're not anywhere close to the final answer. So actually, you know what? I don't know. Leave it in your calculator till the final answer. But I take that back. It doesn't really matter in this particular problem because you're going to look straight at the
Table.
z table. All right. What do we get for this?
1.38.
1.38? All right, excellent. So when we see, let's look at this one first. This 26, z-score of 26. What's the area under the curve associated with that
For which one?
for 26?
Oh, it's, you mean like the,
Yep, the area under the curve this way.
oh, 91.6?
91.6. So like I said, I think the easiest way to do this is find the area above the curve first and make a note of that. So what does that leave above the curve then, Henry?
8.3.
8.36?
8.38 or 8.4?
8.38? Okay. Alright, 8.38. Alright, and then for 19, what's the area below the curve for negative 0.55555?
30.8.
How much?
30.85.
30.85. Okay, so we got 30.85% here, and we got 8.38% here. All we need to know is what does that leave in the middle?
Yes.
So about 42-ish, 40-something percent? Right? You don't like it, Mike? That's it's your answer, right? Right, isn't that the
Yeah,
answer you got?
I
So confused.
I don't like the 30.85, you know, you got from the table. I did it differently, so that's why I missed it.
Wait, what happened, what'd you
8.3.
get?
Well, I don't have the negative table.
Okay,
So what I did was I just subtracted the,
yeah,
that's the, inverse the one.
yeah, it should be fine.
So I do it differently, I just did 100 minus 55 and I got 45%, 30% of it. I could have.
You got 40, okay, let's, alright, so let's, so 45 is much different than 30%, so something's wrong there. But let's figure it out, what's the area under the curve for a z-score, anything less than a z-score of negative 0.555? We do that two ways.
I think I do it wrong,
5.5.
because I just looked at 0.5. I was supposed to look at 0.55, which is,
Ah,
yeah, I get enough, I did it wrong.
So a positive 5.5 is 0.7088.
okay,
So you
So you
subtract that, and we got, what did we get?
That was this number.
Yeah, so we got 29,
Yeah.
29?
2912.
2912.
2912.2912, alright,
Yeah.
and let's put this back in decimals, alright, and what did you get up here? Are we okay up here?
Yeah, that's fine.
What do we have up here, I'm sorry? It
That
was
was a,
point 08,
Those are 8.38.
8.38, okay, and we can either put
because
8.38%,
because the
or I can just leave it as
26 was
0.08.
9162.
Oh, so we
And so
subtract that
to
from
get that,
100.
yeah.
Got it.
So we got this
Okay.
part already.
Okay.
Alright, so what do we get when we subtract both of these from 100?
Calculate.
Okay, wait.
That's when we get to
So
42 something, right?
isn't it, it's 100 minus 29.12, right?
And minus
And minus the,
0.0 or 8 point. You can do 100 minus 2912 minus 8.38, or you can do 1 minus this minus this.
62.5.
Yeah, that was it.
Yeah, okay, I guess that's right.
That's,
Yeah, that's right. Yeah, of course. Okay, so that's 62.5. Is that what you got initially?
we were like, what?
I was like, wait, how did they get that?
Okay,
That was too
62.5.
wrong.
Oh, but 0.625.
Can you do the, on the board, can you do the math for,
It's got two different people.
Oh, for the z-score of 19?
for the negative z
We
score?
did it 3 times.
Negative z-score?
Yeah,
Yeah.
This one? So
Yeah.
19 minus 21 gives us,
I mean, just inverting,
Like-
like changing it to a positive, the negative minus.
oh, to get the,
Yeah.
the
without-
29?
Without the table.
Okay, wait, I'm not sure what you're asking me to do. So, you're asking me to look on the z table at
Well, you said if you
0.55?
don't have a z table, there was a way to.
Yes, okay, so look, if you don't have a z table, you look at, you look on the back of the slides here.
Yeah.
You look at this. Alright. You look at this, yeah, this one. Okay, look at this. And you look for 0.555. When you see, so you might look for 0.56. So look at that z table and tell me what you get when you see 0.56.
0.7123.
Alright, so you get 0.7123.
Choose it.
Alright, what
Yeah,
that means
63.
is that, so here's the middle, and this is the middle, this mean, this is equals the middle, mu.
That's,
Alright.
I know where I messed up, though.
And you found the positive side here. You found 0.56. So you found everything below this as 0.723. Alright, but what we want is if this were on the negative side, what would it be? So to get that, we take 1 minus this, and we get,
Oh, it's actually different if you do
I
the
did one
0.56. So it's 2877.
I know what you're doing.
okay,
Yeah.
or
Yeah,
28,
we did
Yeah.
5.5, so.
We did
Okay.
it for 0.55.
29.2, 28.77. Okay, so that would be fine, because that's, you do the best you can with the z table.
So obviously we're rounding up if it's more than if it's a 5 or above,
So-
Yeah.
right? Okay.
Yep,
So wait, so it's really 0.2877? 1 minus 0.7123?
0.287, yeah.
Yeah, okay,
Mhm.
okay.
Yeah, because we're wrong.
or, okay, or,
I mean, as long as it's close, right? It's,
well, it's as close as you can get when you're looking at the Z table.
I think 5, 6 is more accurate because it's 5, 5, 5, 5, 5, 6.
Right.
Yeah.
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 Alright, so then we'll go with the 2 8.
So then,
It's-
yeah,
it's
because
287.
even like, even the 26, the Z-score, is it the Z-score? For
Yeah.
the second one, the 1.38 is actually 1.39.
Okay, so use 1.39.
Okay. So then the right answer would actually be 63.
Okay, alright, good. Alright, let's erase all this before we make ourselves silly.
Too many
Um,
numbers.
You've got the idea. Let's continue with a couple of problems. I think you've got the hang of it. And I think you'll find it's worth us investing, another 20 minutes, 25 minutes in learning this, because this is the core of what we'll do for the rest of the quarter. So let's take a look at a couple of these exercises. Let's go to page 206 and look at exercise number 7. If you don't have the textbook, you should be able to see it here, right? You can see that.
Yeah, that works.
Number 7? Alright, so let's do number 7. So team 1, do number 7, see if you can get answers to A, B, and C. Team 2, do number 7, see if you can get answers to A, B, and C for me. We'll reconvene in 4 or 5 minutes.
Wait, where's appendix A?
Where's
Is this appendix A?
No, this
Oh.
is, what is page 2? It says on the slides, it says 20, what does it say, page?
No,
No, it
says
says to use.
use normal table and
Appendix
appendix A.
Yeah, the table.
Yeah, so that's the Z table.
Oh,
okay.
If you have the Z table, use the Z table. If you do not, then use this.
Okay, gotcha.
Good question.
What I did was I rushed it, and I did 1 minus 0.55 instead of.
Oh, I thought you might have done that when you said 0.45, and I'm like,
So that would be
okay.
positive.
That's what
So
That's
126
I didn't go
and
with it.
4, 94, 95. To the right, to the right is positive. To the left is negative. Right? Okay. Two point three to the left. Okay, so now we gotta subtract one. Okay, so 2.3. Oh, that's interesting. No, because it's, wait, so which one? Oh yeah, the first one is 94.95, because it's to the right. So, it's at all. To the right. Yeah, that's right. 94.5. See, this one we have to subtract. I believe. I think. Where is that? Yeah, you see he's drawing, yeah. Yeah, I think it's pretty Oh my God. You better see, right? This is everything. So what do you do? Oh, like the other ones? Right, okay. Oh, okay, okay, okay. So, 26.
See some learning happening, I like it. I'm glad we're taking the time to do this.
0.67, that's positive. So
You can figure out everything with this, it's just, this one's just a little bit hard. You have one of these? What do you got? Oh, yeah, you got it right there.
So for this one, you don't need to do that, initial calculation, right, because you already have the.
Oh, that's right, for this one, Henry?
For and
Yeah, exactly, for this one, you can just look at it. Okay.
Yeah.
So then you subtract both of them. Right?
Yeah. Yeah, it's already. The left hand this one, right?
Right, the 2.22, so that's why I subtracted it. So we all have the negative. Yeah, so this
I'm not sure if I did, since we don't already have
how do
this.
we,
we're gonna have
let's
to
go
do
over
initial,
C.
So C.
calculation.
So you want to go straight to the C-stone?
Yeah, that's what I did.
Point
Yeah.
2.15.
I think that's how, I'm not sure. But with round, it's
Okay, oh, it got me, yeah, it got me.
So
So
we,
we're,
since
And
we
it
were
says
on
add-
5,
is
add
98.
up zero,
Oh, no,
that
don't
point,
worry.
so it'll be pretty much, that's what moves to 4.5.
You subtract that,
yeah,
And the same
and
for
then
this
you
one.
just look at
I'm
this
not sure
number,
about
since
the
it's
other one.
positive.
at 60,
Are you
yeah,
doing it
that's
like that,
fine.
where you just
So
find the
67.
C-score? Just go the tables of
Yeah.
1.64 is
746.
this right here,
That's fine.
94.95.
Wait, why did you subtract? Oh, you
Because
said,
you
okay.
find the area in the
Yeah,
middle.
no,
I
I thought you were doing the same thing. I was like, no, this is-
Oh, no,
I
no,
got it now.
yeah.
Alpion.
That's how you put it.
So this I think so.
So let's do it the way he likes to do it.
Yeah,
So,
okay.
how do you know like, I think that actually makes more sense. So,
Okay, 9.1.97.
So, okay, explain that way to me, because I don't get that, the way that he does it.
so he basically looks to this. Right, I'm trying to say you know this. So this one is a Z-score of, which one?
Of the second number, which is
67, right?
Mhm. So this one, okay, wait, let me write it down. 2.15,
Mm-hmm.
and this one's 0.67.
Or,
So,
what I do, I just,
Yeah,
so I got the score for
I
both of
believe
them,
so.
and then it says, starting at 2.15, which is
1.58.
1.58, I mean, yeah, 0.158,
Oh,
and then ending at 0.67.
So that one's to the
0.67,
0.67 is to the right of the mean, so that means it's positive.
It's
Yeah.
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 But I feel like there would be more. This would technically be one.
2.15?
No, cause you're subtracting.
Oh.
No, I
lost
think,
one.
nope, this is
Reverse.
6-7, this is,
215.
because if this is a negative one. This is a negative one, so this is 2-7. Yeah.
215, yeah,
So
yeah.
that's what it is.
Okay. Okay. So this is 2.15, and this is it.
So he took, so he does this,
Mm-hmm.
what is this again?
Are we ready to reconvene?
So he's just taking 100.
Yeah.
The total is 100.
I think so.
How are you all feeling about this?
He's
I
just
still, I
taking
see lots of
this.
learning happening over there, that's why I don't wanna jump in.
So this is
Do you,
How do you
do you
get
have the
70?
answers to,
So
see?
essentially,
Um,
what
this
we
from
do
here
is
that
we
way
just go find the
is
percentage.
So for A,
from here this way is.
And what'd you get for A?
15. I can-
94.95,
Oh,
I think.
okay, and then what?
I could go with that.
And so he's just taking
You got
the sum of
90,
this
is that what
and
you
the
got?
sum of that and minus it.
No? What'd you get?
The sum
Completely
of
fine. I
this
think
and the sum of this.
charged up the question.
So these.
Alright,
two
we can look on the
minus
table
Mhm.
for 1.64, right?
Yeah,
What do you get? What do you see?
1.6.
Oh, we did problem 8. Did
0.9495.
you just say do problem 7? Did you say we did problem 8?
Problem 7, right?
So you're saying
Yeah, you
that
did
gives
problem
us
eight.
that?
Oh, that's fine, we're gonna do 8 next.
Yeah.
That's alright.
You didn't do 7. I thought you said they did 7. What did you
Yeah. It should.
Oh,
it looks
I
like
did 7.
Alright, we're doing 7 now.
No wonder.
Well, this is
Oh,
really
hey,
supposed to be
I was-
1.58.
That's all I'm confused over here.
I'm hearing some
Oh,
numbers
right,
here, some
right.
numbers
So
here,
do
I'm
like
trying
that,
to
like-
like, I'm trying to like mend.
Alright, we'll do 7A right now.
Oh.
Tell me what you get. When you look up 1.64, what do you see?
0.9495.
0.49495.
Yeah,
Point.
9495.
Okay, so 0.9495.
We're off.
Alright. Is that what you get?
Yep.
Yeah, alright, so 94, 95% of the data is below that. That's fine. Alright, how about B? Point starting 0.233 standard deviations to the left or mean. So find the area at or below the point 2.3. So we're looking for at or below, we're looking for this.
Oh, I missed that one.
0.9901.
0.9901. So you're telling me 99% of the data?
No, I
No,
got
it's the other way
zero
around. I
Oh,
missed that
point
one.
zero
yeah.
zero
No,
nine
yeah,
nine.
yeah.
It's a negative.
It's 1 minus that.
Yeah.
Yeah,
What do we
so
get when we get 1 minus that?
We got 0.99%.
Yeah.
0.99%.
99%.
So less than 1%.
Yeah.
Okay, good. So, and sometimes it's confusing, we could write it 0.99%, or we could put 0.0099.
Yeah.
And you know those two things are the same, right? We'll use them interchangeably, you just need to not be scared by that. Alright, so that's the answer to that one. And then for this one, we're looking for the area in between, right?
Yeah.
Alright, what did we get for an answer, anyone?
Maybe 73.
73%?
73.28.
Yeah, that's correct.
73.28%?
Yes.
That's
Yeah?
around there.
Okay, good. Excellent. Let's do number 8, since we've already got a head start, let's do A and B for number 8.
We did, if I read it right, I did 2.5% beyond the point
Out
to the right.
beyond.
That sounds, yeah, oh yeah, that's right. That's right.
Out
Well, we'll
beyond.
give team 1 a minute to catch up though.
Wait,
That's
what?
right.
No.
No wonder all.
Oh wait, we have to do those. You want us to do?
Just do A and B.
Out beyond.
Out beyond. Oh god, that sounds so scary.
It does. It's very intimidating.
I think that was what was confusing me.
It just means from that on. They just wrote it.
So, oh, okay, so
yeah,
they're just,
yeah,
okay.
They just